12, and welcome to Purple Mountain Maths. Today we're doing the 2025 HSC paper for Mathematics Advanced. This is part 1, the multiple choice. Question 1. The probability distribution table for a discrete random variable x is shown. What is the value of the probability when x equals 3? Pause here to try yourself. We know that the sum of all the probabilities has to equal 1. So far, they add to 0.6, so the missing number has to be 0.4. The answer is B. Question 2. Which graph could represent y equals 4 to the x? Pause here to try yourself. Okay, we're looking for an exponential. It's certainly not linear, so we can eliminate C and eliminate D. Because the base number is 4, it's more than 1, we know that as x goes to infinity, y will also go to infinity. So we're looking for an exponential that meets that criteria. The answer is A. Question 3. What is the domain of the function y equals the square root of 6 minus x squared? Pause here to try yourself. We know that the square root is 0, so that's fine. We just need to keep the algebraic expression under the square root positive or 0. So just rearranging and solving that. As I multiply both sides by -1, I need to flip the direction. So x squared is less than or equal to 6. That means that x is trapped between positive and negative root 6. Inclusive, so I'm looking for square brackets. The answer is D. Question 4. Which of the following best represents the graph of y equals minus 5x outside of x minus 2 outside of 3 minus x? Pause here to try yourself. With an expression like this, I would really rather see it in the form of x minus alpha, x minus beta, x minus gamma, because then I would know that the roots are at alpha, beta, gamma. I can achieve that here by changing that minus sign out the front by swapping the direction of the final term. So I can turn it into y equals 5x outside of x minus 2, outside of x minus 3. Now I know that the roots are at x equals 0, x equals 2, x equals 3. And I also know that the coefficient of the x cubed is going to be positive 5, which means that as x goes to infinity, y goes to infinity. The answer is C. Question 5. What is the indefinite integral of 1 over root x plus 5 dx? Pause here to try it yourself. It's helpful to me to rewrite that with a negative index as so. Now I know that when I increment that index, it'll go up to a positive half, and I need to divide by that half plus the constant of integration. So I'm looking for an answer of 2 outside root x plus 5 plus c. The answer is B. Question 6. The graph of y equals f of x is shown. Which of the following is the graph of y equals minus f of minus x? Pause here to try yourself. So when I look at the structure of y equals minus f of minus x, I know that it's been reflected in the x-axis because of that outside minus sign, and I know it's also been reflected in the y-axis because of the inside minus sign. It doesn't matter which order I do that in. So initially I could consider just swapping in one axis and then moving to the other. And notice that those asymptotes move too. So the asymptote, which used to be at x equals minus 2, it's moved to x equals positive 2. The asymptote, which used to be at y equals positive 1, is now at y equals minus 1. So I'm looking for that curve. So the answer is C. Question 7. A 10-sided die has faces numbered 1 to 10. The die is constructed so that the probability of obtaining the number 1 is greater than the probability of obtaining any of the other numbers. The numbers 2 to 10 are equally likely to occur. When the die is rolled 153 times, a 1 is obtained 72 times. By using the relative frequency of rolling a 1, which of the following is the best estimate for the probability of rolling a 10? Pause here to try yourself. Okay, so let's think about this question. We know that the possible scores are 1 to 10. 1, 2, 3, and so on, up to 10. We know that the probability of obtaining 2 to 10 are equally likely. Let them equal little p. And the probability of obtaining a 1 is different. Let's call that Q. But in fact, we know what that is because we're told that it's 72 on 153. So the probability of obtaining a 1 plus the probability of obtaining all the other numbers has to add to 1. 9p equals 1 minus Q, which is 72 on 153. 1 minus 72 on 153 equals 9/17. So 9p equals 9/17. 1p equals 1/17. The answer is A. Question 8. The minimum daily temperature in degrees of a town each year follows a normal distribution, with its mean equal to its standard deviation. The minimum daily temperature was recorded over 1 year. What percentage of the recorded minimum daily temperatures was above 0 degrees? Pause here to try yourself. Okay, so in this question, we know that the mean, which is mu, and we know the standard deviation, which is sigma. In this particular case, mu equals sigma. We know we have a normal distribution, so it's centred on the mean. And these questions normally involve understanding what's going on. 1 standard deviation above and below the mean, 2 standard deviations above or below the mean. But in this particular case, because mu equals sigma, we know that 0 occurs right here. 0 is 1 standard deviation below mu because mu equals sigma. We also know in these questions that within plus or minus 1 standard deviation is 68%, so 34% here and 34% there. We also know by the symmetry of a normal distribution that 50% is above the mean and 50% is below. So in this particular case, it must be 34 plus 50, 84% is above 0. The answer is D. Question 9. The diagram shows the graph of y equals f dash of x. Given f of 1 equals 6, which interval includes the best estimate for f of 1.1? Pause here to try yourself. Okay, notice that we are given the first derivative. We're especially interested in what's going on around x equals 1. And we can see that this point here is 1, 2. So we know that f dash of 1 equals 2, which is positive. A positive slope tells us the original function is increasing. We can also see that the slope of this function is negative. A negative slope tells us that the second derivative here is negative, which means the original function is concave down. So let's visualise what that original function must look like. We know that it's increasing and concave down, and it goes through the point 1, 6. If we consider the tangent at this point, the slope is m equals 2, and we know a point. We can use y minus y1 equals m outside of x minus x1. Y minus 6 equals 2 outside of x minus 1. So y equals 2x minus 2 plus 6. this is the line y equals 2x plus 4. So at x equals 1.1, this goes through y equals 6.2. And we know that that line is a little bit above the curve, so the point 6.2 is not included. The answer is B. Question 10. The graph of y equals f of x with all its stationary points is shown. How many stationary points does the graph of y equals f of e to the x have? Pause here to try yourself. Okay, they're asking us about stationary points, so they're inviting us to differentiate. Y equals f of e to the x. So the first derivative is f dash of e to the x multiplied by the derivative of e to the x. We know e to the x is special because its derivative is precisely itself. So the first derivative, e to the x, f dash of e to the x. Now stationary points imply that the first derivative equals 0. So let's set that equal to 0. By null factor theorem, a product is 0 if the first factor is 0 or the second factor is 0, but we know that e to the x can never be 0. So it must just be when f dash of e to the x equals 0. That's when the stationary points will occur. So let's go back to the original curve. We know that we're inputting e to the x. That means we can pretty much ignore the left-hand side of the curve. We are never going to be feeding that function a negative number because e to the x is greater than 0. We can see that there will be a stationary point around when e to the x equals 1 and another one when e to the x is a little bit more than 2. So there will be 2 stationary points. The answer is C.